Hello and welcome back to the channel. And today I'm starting a new series, which will be in which we will be creating a 2D platformer game in Unity, and I'll be going for this classic platformer vibe that you might know from games like Sonic or Mario Brothers. But I will be using a free set of graphics so that all of you can follow along. And in this first episode, we will handle the basic player movement and jumping and ground detection. So here you can see that I have Unity open. The version I am using is 2021, but you could use the newer version if you'd like. I also tried out the alpha version for 2023, but it seems, well, buggy and not performant enough to actually build games with. So probably we'll have to wait for some kind of beta of that to start development. I set up the project using Unity Hub, and I created it by using the standard 2D core preset. So this is how you can just click it, name it here, and create your project. Okay, so starting now, one thing that I would like to change definitely is set the aspect to 16:9, and we're gonna use that. And as I want to handle some kind of basic movement, I would like to have a floor for my character to move on. So let's create 2D object sprites, and I'm gonna use a square, and I'm gonna position it at the bottom. So let's move it. I'm gonna hold Control, then just move it down to minus 4.5, and then I'm gonna scale it. Also holding Control so that this is done with the increments of 1, and 18 is fine. So this is a transform for my floor. I'm gonna name it as a floor here in my hierarchy. And I assume that you have at least a basic knowledge of Unity, but I will try to explain as I move along. So it's not impressive when it comes to graphics, and we're gonna work on graphics probably in episode 2 or 3. But I can also add another 2D object sprite, and that's gonna be another square. I'm gonna name it player. Okay, and I'm gonna change the color to black just for it to be different. Okay, well, let's talk about our floor first. This is gonna be obviously an obstacle that our player should collide with. So we're gonna need a rigid body, 2D, and we're gonna make it static. And this is basically the body type that you're using whenever you're working with something like a floor or a wall, just something that isn't moving, but something that our player should collide with. And also I'm gonna add box collider 2D. Okay, and this is the simple setup. Of course, if we press play now, nothing will happen. We have to modify our wonderful player to add the rigid body and box collider. So let's go and add the rigid body. It's gonna be rigid body 2D, and I'm gonna make it dynamic so that the forces of gravity and stuff like linear drag can affect our player. I'm gonna press play, and it's gonna fall through the floor, of course, and this is due to the fact that we don't have a box collider. Okay, And now that basic setup, I assume they're gonna collide. Okay, great. So this is our basic setup. We have a collider, basically two colliders now. Now I would like to make our player movable. So to actually move our player, we need to read the input from the player. So I'm gonna create a new sorry. I'm gonna create new script and call that player movement. And I'm gonna open it in the IDE. Basically, you can use any type of IDE that you'd like. I will be using Rider because I have a license for that, but using stuff like Visual Studio or Visual Studio Code, or even built-in, because there is built-in code editor. Let me see. It's called how is it called? Script. Let me see. Free Unity, something like that. Script Inspector free. So basically, you can buy this add-on. Sometimes it's on a sale. Oops. Sometimes it's on a sale, and it will allow you to write the code inside Unity itself. So this is pretty cool. Yeah, I purchased that item. So it's very basic, but it's kind of cool because you don't have to leave Unity to write your code, and it has some basic features like highlighting some errors or autocomplete. But other than that, I would stick with Visual Studio or Rider. Okay. So first thing I'm going to do is just drag that code and apply it, that script, and apply it to my player object, right? And now I can start coding. And we're gonna need some variables here, preferably some stuff that I can modify from the Unity engine itself. So I'm gonna say I need the speed. I'm gonna initialize it to 5. We're also gonna need to handle the jumping. That's gonna be float. I'm gonna say jump force and also set it to 5. And we will need a reference to the Unity components. This up so you can see that better. And that's gonna be rigid body 2D. And I'm gonna call this rigid body 2D. And we're gonna need a reference to the box collider. So or I don't even have to write private box collider 2D. Box collider 2D. Okay, default names are fine. Yeah. And in the start, I'm gonna get the references that I need. So rigid body 2D is get component. This is of course generic. So this is rigid body. And then box collider is the same, but we're getting the reference to the box collider. And if you don't know, this is going to reference the components that we have here applied to our game object. So basically, that rigid body 2D is the component that is on our game object. So in this case, because the script is applied to player, this is the rigid body of the player. Okay. Let's see. We will have to calculate the velocity of our player based on user input. So the way we can get the user input every frame is in update. Here it is stated that this is called every frame. I can just say that I can get input from my player. I can get the axis and I can get the horizontal axis, which will refer to A and D button presses. Okay, yeah, I could just say that my rigid body velocity would be equal to, and as you can see, the types are not matching because this is a vector 2. I can just create new vector 2. And here I'm going to say just for y-axis, for now, reapply the rigid body velocity y. Right? And this should allow us to move our wonderful game just a little bit. Let's see. Yeah, it is moving, but it is moving rather slowly. But we can already see that we have something going on the screen. So let's stop that. Of course, we have the speed here for a reason, and we can use that as a multiplier here. Okay, and now okay, now we're moving a little bit faster. What is cool is that we can actually, when in a game and when the game is actually playing, we can increase our speed like 15 and it's going to be automatically applied. And now the movement is even faster. Okay, so yeah, we have our basics here with just a few lines of code, so this is cool. Okay, moving on. There's one thing that we definitely would like to do, and it is we could apply another vector to our velocity whenever user presses space to jump. So I can just ask whether the button was pressed, and that's going to be get key down, and here I can provide the key code, which is an enum, I believe, code space, yes, and then I can say that rigid body velocity, add to that new vector 2 and add a jump force for a y. Okay, but actually what could be a little bit better is instead of referring 2 times to the rigid body, I could just create private vector 2 called velocity, right? And just say that we're using velocity here and here. And then at the end of our update function, once we have calculated everything that we need, we can just say that the velocity, or that the rigid body velocity is the velocity, right? Okay, and that should allow us to jump. Let's try that. Okay, so I am moving as I was before, but now I can have my character jumping, right? But as you can see, I can make him jump basically infinitely. Maybe it's something that you'd like. For example, if we were to create a game like Flappy Bird, right? We'd probably use that to somehow maintain your bird on the right path. Maybe you'd like to have some kind of double jump in our game, but in our case, we're just trying to have, for now at least, a simple jump. So to make our character jump just once, we have to know whether he's on the ground or not. And if he is on the ground, then he should be allowed to jump. But if he's in the air, so-called in the air, not touching the ground, we shouldn't be allowed to jump anymore. So let's try that. Let's try and implement that. So I'm going to create a new function inside of our class. It will return Boolean because it will inform us whether the user is on the ground or not. And I'm going to call that is grounded. And there are a few ways to determine whether the user is on the ground. But for now, we'll use raycasting. Right, so basically, we will cast a ray from the center of our player and see whether it touches the floor. And if it does, right, the ray is gonna have a limited length. And if it does, well, then that's the information that we had actually touched the ground. So you can use the raycast hit 2D to have the information about the raycast. You can cast the ray using physics 2D raycast, and we have to provide few information here. Right, so first gonna be the origin. We will have the reference to the box collider 2D of our player, and we can use it bounce, find the center, and use that as an origin of our raycast. Then there is a direction, so we're going to use the vector 2 down because we're trying to cast ray from the center of our player towards ground. Then we have to calculate the distance, so how long should be the ray. Okay, so I'm going to use the box collider 2D bounce, and there's this property called extends, right? This is always half of the size of the bounce. Okay, so this is cool because we're shooting from the center, and then we're checking using the Y value. But that's not gonna be enough because that's gonna cast the ray from the center of our box collider to the extents of our box collider. So we need to add just a little bit of value to make it actually extend towards the ground and outside of our player, right? So I'm going to define a simple variable here, and I'm gonna use extra height check, right? And I'm gonna provide a value like 0.1 should be enough. So here I can just add this, okay? And we're gonna be golden. Okay, and then we can check whether we are actually hitting something. But just for the debug purposes, I'm gonna create a ray color here because we can draw that ray in our game. So that's going to be raycast hit 2D, and I'm going to see whether we have a collider, meaning whether the raycast actually hit something. Check for null, and if it's not null, that means we have hit something. So the ray color is going to be color green, else ray color is gonna be color red. Okay, you can draw the ray. So it's gonna be debug. Oops, not that. Debug draw ray. Okay, and then you can use the box collider. Bounce center. Vector 3, we have actually we have to specify vector 3 here, and we don't need those parentheses. Vector 3 down times box collider d bounds extends y plus extra height check and ray color. Okay, we will return with a ray cast hit to D collider is not equal to null. Okay, so that should allow us to draw the ray on our screen. So let's try this. And it's not visible. Oh, and this is of course because we're not calling that function at all. So this should be allowed only if we are grounded, right? And input is space. Let's try that again to see whether that works. Let's hit play. And it still works. Oh, but now we have in our scene, you can see our ray, and it's green, meaning that even here in the air, we are hitting something. And that's true in case of a raycast, because we are casting the ray from the center of our box collider, and it goes down and it hits itself, it hits the player. So we have to find a way to actually exclude the player from that check, right? Okay, so as you can see here, we have different layers for different things, and we can use that to decide on which layer should we perform the raycast test. So I'm gonna add, let's say, floor, or maybe even better, ground layer, and I'm gonna rename this to the ground. Okay, so I'm gonna leave the player on the default layer, but here I'm gonna say that this is a ground layer. And I would like to somehow use that information about the layer in my code. So what I can do is define a layer mask that can be serialized. So serialized field, private layer mask, platform, let's say ground layer mask. Okay. So when our script is gonna recompile, and here I can see that I have a drop down from which I can select ground layer mask, and I'm gonna choose and check only ground. And then here in my physics raycast, I can add additional parameter. It's gonna be ground layer mask here, and also here. right? And now I can see that we have some squiggly lines and see whether we can do something about that. You can see that we have repeated property access of built-in component is inefficient. Okay, so we're accessing this property and this property 2 times. So I'm gonna create a variable here and call that, let's say, raycast distance, right? And I'm gonna set it to that value. Okay. Why is he mad at me? Cannot access. Since I messed something up with my parentheses. Or did I? Why is this just a static context? This is good, this is good. Oh, let me just... Okay, that was strange. Let's try this again. Private. Oh, just call it maybe float. And say that this is again raycast distance. I don't know what was wrong. So, and then I can just reuse that here and reuse that here. Okay, what's the next problem? Repeated. Oh, okay. Then it's mad about the origin. Cool. So let's fix that. And that's gonna be vector 2, right? Vector 3 action. Okay. Vector 3 raycast origin. We're gonna create that variable here. Use it here and here. Okay, let's see what else. Comparison to null is expensive. It might be the true. Let's see. Can I fix that somehow? Not really. Let's leave it at that. Okay, this also seems to be a problem, but I'm not gonna be super performant with that code. I'm gonna say that creating those variables is enough. So yeah, let's try that again. Okay, so now we landed, and you can see that now the color of our array is changing based on the fact where we are in the air or not. And now if I'm in the air, I cannot double tap the space to jump twice or jump higher. So that's cool. And we have the basics set up. Probably in the second episode, I'm gonna refactor a code a little bit to use the new Unity input system instead of taking the input directly through the input class. So yeah, that's that, and I hope you liked it, and thanks for watching, and see you in the next one. Goodbye.